So in this demo, we will build the basics of our IoC container. But first, just as before, let me cut out the code from the previous demos here and put them in a method of their own, so you still have them for reference later on. There we go. To start, let me paste in the class structure we just saw on the slide. So let's add a new class and let's name it IoC example classes. So let me paste that in and let's run through it. We've got an iCoffee service interface here. That's the contract all our coffee services must adhere to. We've only got one implementation of it, coffee service. Coffee service is dependent on an iWater service. I commented out the second constructor, in which it also depends on a generic iBean service. That's something we'll tackle in the next demo. Let's keep it simple for now. If we look at the water service interface, we've got one service that implements the iWater service interface, tap water service, and we've got one service that implements the iBean service of tea, the Arabica bean service of tea. Lastly, we've got a helper class, Catimore, which is a variety of the Arabica coffee bean. Alright, that's it for our helper classes, and they match what we've seen on the slides. Then let's add a new class to our project. We'll name it IoC container. We need this to contain a mapping dictionary of type. By that I mean the contract type as the first generic type parameter and the implementation type as the second generic type parameter. What it also needs is a register method to register the contract and implementation types. We'll make this a generic method in which we check if the mapping dictionary already contains a key of type contract, and if it doesn't, we add one with the type of the implementation as value. So like that we can register contracts and corresponding implementation types on our mapping dictionary. What a typical IoC container also contains is a resolve method. This is the method used to resolve an instance of something that adheres to a certain contract type. We'll make that a generic method as well. We ensure that it accepts the contract type as generic type argument. What it returns is also of type tContract, as that is what we're trying to resolve. First thing we check in there is whether the mapping dictionary contains a matching key, and if it doesn't, we throw an exception. If it does contain a mapping key, we need to create an instance. And this is where we can use a bit of reflection. Let's create that create method. This is a private method that works on the same generic type argument, tContract, as that is what it needs to return. The power of generics really shines through here. Currently, we'll simply assume that we want to use a parameterless constructor, and we use the activator to create a class instance. So this code isn't finished yet, but we can already give it a try. Let's save this, and let's switch to our program class. The first thing we do is new up our IoC container. Then we register a water service on it, and afterwards we try and resolve it. Let's put a breakpoint here and let's see if this works. We hit our breakpoint, and we indeed get back a tap water service when we try to resolve something that implements iWater service. So this is looking good. Alright, now let's see whether we can resolve a class that depends on another service. If we look at our helper classes, we've got a coffee service here. That coffee service depends on an iWater service. We're not dealing with generics yet here, that's coming up later. So let's try registering a coffee service on our container. And after that, let's try resolving it. And let's give it a try. And we hit an exception. the constructor onType reflection_sample.coffee service wasn't found. Well, that makes sense. We are assuming that we want to use a constructor without parameters. But in this case, our constructor has a parameter, one to be exact, something that implements IWater service. So we will have to change our create method. Instead of passing through null for the parameter list, we need to pass through a set of objects to the constructor. And these objects will very likely have to be resolved as well. So let's add a variable to hold the constructor parameters and let's get going. We want to start by selecting the correct constructor. But what is the correct constructor? The thing is that this is not a simple question to answer. Containers could solve this by providing the ability to register the constructor to use. Another option would be to use marker attributes. We are only writing a demo here, so for the sake of simplicity, we'll simply assume that the constructor we want is the one with the most parameters. At least like that, we can be sure that most dependencies will be resolved. So we order our constructors, descending by the amount of parameters, and we select the first one. From that constructor, we then select the parameters. We call into getParameters for that. But that's not enough. We need to resolve them. And to resolve these parameters, we need to call the resolve method on our container. As you know, reflection is expensive, so to avoid having to use reflection multiple times when we don't really need it, let me add a field to store the resolve method in so we can reuse it. That's of type method_info, and that's defined in system.reflection. And with that, we've got our variable for the resolve method. What we want to do in our create method is ensure that this resolve method is fetched and stored in case it hasn't been used before. If it's been used before, we can simply reuse it. Otherwise, it will be null, and in that case, we get it on our container. Alright, now we can continue with our parameter list. The resolve method is a generic method, so we need to make it generic by passing through the contract type, which is stored in the parameter type. And then we invoke it by calling invoke on it. We pass through the object on which we want to invoke resolve, which is our IoC container instance. So we simply pass through this, and we don't need to pass through any parameters. And then we call toArray on it, so we have the constructor parameters. This results in an array of constructor parameters, and these are the ones we can now pass through to our createInstance method. Alright, let's give that a try. We hit our breakpoint. That's looking good. We didn't crash this time. And if we look at our coffee service, we see that it indeed resolved. So this time it works as expected. In the next demo, we will add support for constructor injection.